Alright, we're going to look at the problems related to concept 24. We have number 6, a primary school in England reports the mean height of its students is 1.4 meters. Standard deviation is 0.15. Determine whether each statement is true or false. Student measuring 1.6 meters is 0.2 standard deviations above the mean. When you're looking at the number of standard deviations above or below the mean, that is the z-score. So let's calculate the z-score for this student. The formula is the data value minus the average of all of the data values divided by standard deviation. So this student is 1.6, the mean is 1.4 divided by 0.15, and we're verifying whether this statement is true. So subtract those, divide by 0.15. So 1.3 standard deviations above the mean, so this is a false statement. Now a student measuring 1.13 meters minus the average divided by the standard deviation. So 1.13 minus 1.4 divided by 0.15. And notice it's negative because this person is below the mean. Negative 1.8, which means it's 1.8 standard deviations below the average. So this is true. Alright, number 7. A group of doctors collected data on the systolic blood pressure of female patients. The mean was 125, standard deviation is 11. Distribution of blood pressures was normal. What percent of the patients had a blood pressure of at least 120? Okay, now in order to find the percentage, we're going to look at the z-table. The z-table gives you the percentage that the data values will be less than whatever's being asked in the problem. So in order to use this table though, you need to calculate the z-score first, and then we'll be able to look up the percentage in the middle here. So in this problem, the z-score of patients that have a blood pressure of 120 minus the mean divided by the standard deviation. So this would be 120 minus 125 is negative 5 divided by 11. Negative 0.45. And you want to round to 2 decimal places so that you can use the table. We have a negative z-score, so you want to look on the negative side of the table. We're looking at negative 0.4, and then the second decimal place is 5, so go over to the column that has the 0.05. And we have the percent here is 0.3264. This is the percent chance that the blood pressure will be less than 120. This z-table will always give you the percent chance that it's less than. Because it's asking for the percent chance that the blood pressure will be at least, that means greater than or equal to, I need to take this percentage, 32.64%, and subtract it from 100% to get the percent of patients that will have blood pressure of at least 120. So 100 minus 32.64 is 67.36%. Alright, now the last one on this video is the scores on a recent geography test are normally distributed. The mean is 22 points, and the standard deviation is 6 points. So I'm going to just make my normal curve here. 1 standard deviation above, and then 2 above. Standard deviation of 6, so this would be 16 and 10. Determine the test score at which 20% of the students scored lower and 80% of the students scored higher. So if I'm looking for the test score where 20% of the students scored lower, well, I know the percentile, but I don't know the z-score. So I know that the percentile is 20. Why is it 0.2 and not 0.8? Well, percentile is defined as the percent that is less than the value in the problem, so we're going to use the one that says students scored lower. So in your z-table, you're going to go ahead and find 0.2, but 0.2, remember, is not the z-score, it's the actual percentage, or the percentile. So I'm going to look for the one that's closest to 0.2, get as close as you can. So here, getting warm here, 0.2005 is the closest one. That's the percentile. But since I'm looking for the test score at which that happened, I need to know the associated z-score. So for the 0.2005 here, the z-score is negative 0.84. So z equals negative 0.84. Now that I know the z-score, I can work backwards to calculate the actual test score that this person got. So equals the z-score formula. I don't know the test score, but I know the average was 22 and the standard deviation was 6. So solving this equation, I'm going to multiply both sides by 6, and then I'll have to add 22 at the end. So the score is 16.96, and we are told here, draw a line on the curve to right to indicate your answer. So if the score is 16.96, then I know it's somewhere very close to 16, so just approximate. So this again tells you that at this line, 20% of the students scored lower than that, 80% of the students scored higher than that.